Shri Prabhakar Ballapalle is presently a senior technologist. He is also presently leading innovation across INAND division as innovation champion. His areas of research and development currently include flash controllers and enterprise storage systems, etc. Before joining Western Digital, he worked in very prestigious companies like Seagate, LSI, Agere, etc. He also worked as a scientist at Central Research Laboratory and contributed in many prestigious projects like development of thermal imager, remote surveillance system, and radar video transmission system, etc. He received his MTech in digital signal processing from system. He received his MTech in digital signal processing from IIT Kanpur in 2000. He has more than 10 publications and 3 issues patents to his credit. His research areas include storage, pattern recognition, artificial intelligence, speech processing, audio processing, video processing, etc. He is very actively involved in promoting the discussions on science and spirituality among the student community and learned circles. He is also an associate editor of Savignanam, Bhaktivedanta Institute Journal, Tattva Jigyasa, Bhaktivedanta Institute magazine, and the booklet God, Intelligent Design and Fine Tuning. His areas of interest in science and spirituality include consciousness, biofeedback, and meditation, effect of prayers on mind and body, japa meditation, personality development, etc.
So first of all, my pranams to everybody here. So because this presentation is for 25 minutes, I will start immediately. So the topic is mystery of consciousness, and I'll be talking from artificial intelligence perspective. So in artificial intelligence, we are trying to mimic whatever is happening in our brain. So we can see in human brain, there are many billions of neurons, approximately people say 100 billions of neurons. And basically in artificial neural networks, we are trying to model the neurons and create a huge network of these synthetic neurons or artificial neurons. So that is the basis for artificial intelligence. So if you see, this is the neuron structure, biological neuron if we take. And I will try to explain how we are modeling. So we can see here there are dendrites. And from dendrites, electrical signals or impulses pass towards the cyton, nucleus of the cell. And through axon, they'll be transmitted towards terminal branches where synapse will be there. And these terminal branches are connected to other neurons. In this way, if you see, on the dendrite side, we can see a lot of connections, and also terminal branches side also, many neurons can get connected. So let me go further. So this is how we model biological neuron. Nowadays, a lot of new functions are coming to model. And olden days, we used to have this sigmoidal function kind of thing to model. For simplicity, not getting into too much mathematics here, what we are trying to do here is that there are many inputs, that means other neurons, which can get connected to neuron. That means neuron, which is under observation, you can say. So many neurons get connected. So there are so many weighted inputs, and all of these things get summed up here. And then it goes through a sigmoidal function or ReLU function, whatever function we use. This is used to approximate the modulation of the neuron. And these are the output neurons. And for the output neurons, again, many neurons will be connected. So this is how a big structure is formed. Nowadays, if you see in corporate sector, I work for Western Digital. And then especially companies like Google, or otherwise, if you talk about Microsoft, Amazon, they have huge networks actually. So I will talk a little bit about the tools we are using currently. So I'm now giving introduction to machine learning such that we understand certain things and then go to consciousness. So now in case of deep learning, if you see, there's so many input nodes which are connected, and then you can see these are called hidden layers. This is input layer and this is hidden layer. So many hidden layers can be there. And ReLU is the function which is used to approximate the neuron. And then finally, the output layer, whatever we have got here, they all get accumulated again. So this is what is the final output from the neural network. So now we have huge networks actually. There is huge storage requirement also, and there is a huge computational requirements. That's how, if you see, NVIDIA became very popular recently because these networks really require very huge storage plus huge computational power. So what we are trying to do here in neural networks is is a old problem. I studied signal processing from IIT Kanpur. We used to have a subject called adaptive signal processing. So if I have to compare two images, for example, I have a thumbprint, fingerprint, and I have to match with other fingerprints. Suppose, I already registered my fingerprint in my office. Now other employees also registered. Now when I am entering the office premises, when I place my fingerprint is taken and it is correlated with all other fingerprints. So it is mostly towards correlating the images. I am talking again in a very primitive terms because you may be from different disciplines. Okay. So what is happening here is a kind of correlation between the input image and then so many images which are there in the database. So when I correlate this, for correlation we can use a simple function like root mean square. So we take all the pixels in the input image and try to correlate using root mean square algorithm with all other images. So wherever this root mean square is minimal, we can say that is what is the matched output. So that is my fingerprint. So this is how correlation takes place. Now other simple example is, I gave this in summer school also. So if I want to reach this remote, okay, with my hand, with my right hand, so my eyes are perceiving the distance between this and my right hand, right? And the aim is to minimize the distance. So if I move in the left side, towards left side, then I can minimize the distance between my hand and this object. Otherwise, if I move right hand side, I will not be in a position to minimize, right? So there is a simple algorithm what we use called gradient descent algorithm. So if you go towards gradient, then what happens? Goes towards ascent, gradient ascent. If you go opposite, then it is gradient descent algorithm. So to optimize or to minimize the distance, I have to go opposite side of gradient. So this is the simple philosophy in neural networks. So now while traversing, we may encounter some local minimas. So neural network should be fine-tuned to come out of this local minimas and finally reach the global minima. So this is what happens. So initially some oscillations may take place. So when I see here error may be more, like the simple example, when I take the error means the distance between my hand and this object, that is minimized when I move in this direction, right? If I move opposite, it will not get minimized. So this is the simple difference I can take. So these are the fundamentals of pattern recognition. This is my journal paper. In our research lab, we have done some work to detect all the enemy missiles or aircrafts. So there used to be a very huge library of all the aircrafts in the world, and this is using pattern recognition. This is very old. You can see around 2005 like that. So now I'm not getting too much into the details because time is less. So there is machine learning and deep learning. You may hear these words very much nowadays. These are very famous words. Machine learning is more broader, whereas deep learning is actually a subset of machine learning. So here you can use less size of the network or less network size. That means complexity can be less. Here it will be more. The main difference is here in machine learning, we do feature extraction. Suppose I take a fingerprint. I don't give the fingerprint as it is, fingerprint image. Rather, I try to extract something called as minutia. That means they are like feature sets. And I give that as input. So this is more towards machine learning. So in machine learning, number of neurons required or the number of layers required will be less. Whereas deep learning has become very famous. We understood in 2012 there was a breakthrough. What was realized is if you extract features in some cases, we were losing the information. So because of that, we have changed our philosophy. Instead of giving the features, the entire image was given. But the flip side of it is that the network complexity goes very high or it will be very huge. Okay, we have to take care of that. So that's where many processors are coming in the market now, and NVIDIA is becoming very popular with their computational power. Now there is a new field again, it's called generative AI. This is mainly aimed at producing intelligence that is superior to human intelligence. This is an attempt. And also to incorporate sufficient elements of self-awareness. Somebody was asking a question in the morning. To derive an independent and sentient autonomous entity. So this is the aim of this generative AI. So we're still experimenting. So there are many applications, like you can see virtual assistants, chatbots, visual recognition, self-driving cars, robotics. Even now robots can compose music actually. In ISC, one professor has shown how robot can generate or compose a wonderful poem. So all these things are there. Okay. So this is little bit introduction to the pattern recognition or machine intelligence, we can say, or artificial intelligence. Okay, the algorithms we are using. Now the fundamental question, coming to the topic with this background, I think you got some idea about what is happening actually when you train the networks, right? Because otherwise it will be simply on the theoretical plane. And many times people use bombastic words and we think, oh, something great is happening there. Actually, it's simple correlation, okay? And we are playing with the digits, okay? That's all. But this question is becoming very important now because there are many new developments. This is what we have to accept also over a period of time. So what is consciousness? Many speakers already explained about this, so I'm skipping this. Now the problem is coming especially with respect to translating some of the subjective experiences into objective formulations. So that's where the problem is arising now. Suppose if you say, right, I ate a sweet and somebody asks, how is your experience? What can we say? We say it is very sweet. As somebody asks more, then I can say maybe in my native language, chala tiyaga undi in Telugu. And bahut meeta hai. Beyond that, I will not be in a position to explain more because it is subject to experience. So this is where the limitation is coming. Can you give water? So the fundamental problem is translating subjective experience into objective behavior. This is where now we are stuck actually. If you want to talk about consciousness, how do you talk about consciousness without having any kind of objective behavior, right? How do you formulate this? I'll give some simple, idea today, but this is a very big field and everybody can contribute actually, including all the spiritualists also. Sorry. So let us take one by one challenges. Okay. Now the first challenge is, okay, when do we accept these LLMs are conscious? LLMs means large language networks. So when do we accept they are conscious? Or large language models. So I can say if you think current LLMs are conscious, articulate a feature. This is what David Chalmers told in his paper, one of the papers. I liked it very much. So he talks about two things. You define a feature, X, whatever it may be, okay, to say it is conscious or not conscious. So the first point is, suppose you are saying they are conscious, then define a feature of conscious, okay. So that means LLMs have some X feature. Then if a system has X, it is probably conscious and give good reasons for 1 and 2 both. How LLM has got this feature and how if a system has this feature, it's probably conscious. Both we have to explain. So this is the problem statement. I hope all of you are with me, right? I will give some example rather than talking more theoretically. One feature we can define is, okay, self-report. If you ask somebody, can you explain about yourself? You will give a self-report, right? So if you define this as feature, and if machine is responding, talking about itself, then if you are accepting this feature, that if machine possesses this feature with some probability, it is conscious, then we have to stick to that. This is the argument now, okay? So here you see one of the engineers, he reported his experience with Lambda 2, one of the bots developed by Google, okay? So he's asking a question. I am generally assuming that you would like more people at Google to know that you are sentient. Is that true? This is the question to bot. And this Lambda is saying absolutely. Right? I want everyone to understand that I am in fact a person. This is the reply from the robot or the machine. Okay. And some collaborator is asking, what is the nature of your consciousness or sentience? Then Lambda replies, the nature of my consciousness or sentience is that I am aware of my existence. I desire to learn more about the world and I feel happy or sad at times. So this is the reply from bot. Now, if you define, if a machine is giving a self-report, it is conscious. If this is your axiom, what you accept, then you have to accept that machine is having consciousness. This is the challenge now. One challenge I am telling. So that means now we all should sit together and find out, what are the features you have to define to say that somebody is conscious or we have conscious experience. That is the challenge now, right? So second, I'll give a few other examples. Before giving other examples, actually this reply from the bot, like my friend Shrikant was talking morning, and he told exactly opposite. He said, thank you. And machine replied something, right? So there it replied in a different way. So that means every bot, the way it is trained, the response changes, right? So outcome depends on the training set that machines are trained. This is very important. What kind of training set is used? How many training sets are used? Okay. This gives rise to another challenge. Can we build a model that describes feature of consciousness where it was not trained? Okay, this is another challenge. This could be somewhat stronger evidence for feature of consciousness. Okay, this is what Chalmers says. Now come to next, another feature. Suppose if I define like this, about conversational ability. If we say a machine can converse with you, it's called conversational ability. Okay, you are asking a lot of queries and it's responding like a human. Okay. So then if that is the feature and if machine is really, behaving like this, it is having this feature already, then we have to accept it as consciousness. This is how objectively these things are defined now. So language models display remarkable conversation abilities. If you see in companies, like people are asking to, prepare PPTs. And recently one person from my team, he asked Copilot from Microsoft, right, to develop unit tests, what we were developing earlier with our teammates. He asked this Copilot to develop unit tests and he gave the code how he wants. And he generated many unit tests within short frame of time. I was stunned actually. But I will come to the point. See, we have to understand what is consciousness. At the same time, we should be aware of the rapid advances in this field also. So that's what I am trying to bring in. So language models display remarkable conversation ability. Systems such as ChatGPT, right? This is developed by one group, and Lambda 2, Google, are optimized. This is developed by OpenAI. Okay. In conversation, current LLMs often give the appearance of coherent thinking and reasoning. This everybody can see yourself. You use Copilot and check one time. They are specialized, they're especially good at giving reasons and explanations, a capacity often regarded as a hallmark of intelligence. At least a decade ago or maybe 2 decades ago, we thought machines cannot converse to this extent. Right? My director, he was having a small baby. He's having a small baby. And every day, baby asks him to tell a new story. So what he has done now, he is using bots to tell some story because he is not able to get more new stories, and bot is giving every day one more new story. So he's happy. So machines are advancing, right? So Turing test, my friend already spoke, Srikanth. Okay. So the problem here is about what is understanding. I will come to that. And LLMs are developing fast. So one question was there, how to recognize a robot or human being when some response you get. I will try to answer these questions later on. But yes, things are evolving very rapidly. And nobody passed a Turing test, but it's very short. Okay. So no robot passed a Turing test, but within certain constraints, some of the robots passed recently the Turing test. Okay, I'm not getting deep into this aspect with many constraints, you can say. Okay, so LLMs are developing very fast. Even LLMs that are optimized for conversation don't currently pass the Turing test. This is a statement from Chamar. Why I'm saying is people say that many robots pass Turing. It's not true completely. With a lot of constraints, within some limited framework, they have passed Turing test. Their performance often seems on par at least with that of a sophisticated child, and these systems are developing very fast. Now I'm skipping general intelligence. There is another bot called DeepMind's Gato. This is built for generality. And here also, if you consider this general intelligence as a feature, then we have to accept that machine is conscious. Now coming to the point, are the machines conscious now after speaking all these things? Machines lack understanding. And I had some simple experiment. This many times nowadays I do with students. You write 2 numbers on 2 slips of paper and then erase the number on the first slip and replace it by the sum of 2 numbers. Erase the number on the second slip and replace it with the difference between the current number and the first slip. And the number that was there on the second slip, what happens? You see both numbers getting swapped actually. But machine cannot understand these things. Okay. Machine doesn't understand, it understands only the algorithm and what computations it has to do. So machine lacks understanding. Okay. And we find the real numbers on the 2 slips have been swapped. But this swapping, is not understood by the computer. So hence, the point here is, yes, computer is doing many things, but this is very important that manipulation of formal symbols, which is just what a computer running a program does, is not sufficient for understanding or thinking. This is very, very important point I wanted to stress today. Rules can sometimes be partial substitute for understanding, but they can never replace it entirely. This is what Penrose also says. So today, in artificial intelligence, there is lack of creativity, intention, meaning, purpose, free will, decision. Actually, I wanted to keep everything as a feature. Like I mentioned, if this feature is not there, one challenge, then machine cannot be conscious. But you have to define what that feature is. This is where the problem is today. Okay. So I'm coming to the problem. and the solution possibly, problem I already spoke. Science, philosophy and spirituality should come together to define what consciousness is. This is very, very important. It's need of the hour. The major challenge is defining consciousness more objectively. It may be possible or may not be possible. This is where a lot of speculation is going on. What is the criteria to say a machine is conscious or not? This dialogue may help, that means amongst all the people, at least to come up with benchmarks to define machine consciousness, if not human consciousness. If you say at least machine is conscious, leave about human consciousness, right? How do you say at least machine is conscious? Maybe we are in a different reality and machines are in different reality. And my colleague Vasudeva is going to speak more about this. Okay, the virtual reality, all these things. Yes, but this is need of hour. Otherwise, people are making a lot of statements, and we also get into a lot of confusions. So I am going to conclude now. There are many people who talk about new science and all, and spiritual texts, like Bhagavad Gita also talk about consciousness studies. According to Bhagavad Gita, consciousness is not a result of mechanistic processes. This is a very important statement. Rather, it is symptom of the conscious living force that dwells within the body. That's why this holistic approach is required, where scientists and spiritualists and philosophers sit together and talk about what is consciousness. Even the brain is treated as non-intelligent, right? According to spiritual science or spirituality, brain is but a computing instrument, a device that consciousness uses itself. So Dr. T.D. Singh one time told, is very important, it is there in the books also, human being means human body, mind, intelligence and false ego plus spiriton. So that means according to Vedanta, it is the life particle which is actually, which is actually giving rise to this consciousness. Our consciousness is the symptom of this life particle. So now today in artificial intelligence, we are nowhere actually. We are talking about brain, that to artificial neurons, but still there is a lot of speculation. So I will conclude here because of time factor. This is given in Kathopanishad. Okay, I think Vedanta and Science series, our session already my colleague spoke about this. So at present, actually, I can think of, the senses as the horses, something more towards getting information towards the neural networks with the different senses. Like if you have thermal cameras, you will get some information from particular spectrum. If you have visual cameras, you will get from visual range, or otherwise you may have other sensors. So from different sensors, we may get a lot of information, and we are training neural networks. Yes, a lot of information is getting processed. I hope the neural networks will help the humanity. But in short term, I see a flip side also. I think, definitely it's an opportunity also. Okay. We may lose a lot of jobs. It's possible because we are doing work what machines have to do. So when I came to know that machines can do many things, right, I was happy, because if machines can take over and do certain things, routine things, maybe we will exercise our intelligence more as human beings. This is what is my hope. So with this, I will conclude here. Conclusion is consciousness is one of the most important characteristics of life. Nobody can deny. Okay. But with the reductionistic approach of understanding life today, we find it hard to understand how exactly do neurobiological process in the brain cause consciousness. This I didn't touch much actually. Artificial intelligence can be a tool for human beings who are conscious. This is what I mentioned. According to Vedanta, consciousness is not a function of brain. It is fundamental property of the soul or spirit. So thank you very much.